Hi guys, my name's Ian. This is part 2 of my solution for lesson number 7 in Paul McWhorter's Arduino with Python tutorial. Part 1 was the Arduino, so we've had a quick look at the code and we've had a look at the results, and just to refresh you, that's what we have. We've got the pot, the two DHTs, and we've got data coming from it streaming up and down, and if I give the tweak you can see, there we go, very nice. So for this tutorial, or this part of the tutorial, we are only interested in the CSV data at the moment. It's coming over to Python. What do we do with it? So crucial point, there are 5 pieces of data separated by commas, and at the end of each line there's a carriage return line feed. The data is as follows. If I disconnect and highlight it, so you've got the pot value, comma, then the DHT11 data, which is temperature, then the humidity, and then the DHT22 data, which is again temperature and humidity, and the accuracy is I don't know, what is it, 18.9, that says 19.1. That's not bad for the 22. Anyway, let's have a look at the Python code now. That's what this part of the session is about. So here we have the Python code. So lots going on in this Python code. Quite a big change from what I had last week. Last week it was all just which is a linear block of code. There was no classes, there was no functions. I've watched some other tutorials, well, some other solutions by, I think Keith Lohmeyer has done quite a lot of work. I've watched what he did. He had some great ideas to do with classes, so I've borrowed his examples and I've played with it myself, and it has been a lot of work, but I'm quite happy with the results. The results are, I think, quite good. I'm very pleased with it. Anyway, let's jump into it. We've got a bit of canvas going on here. This is a command that Keith put me onto. You can basically set yourself up, instead of having it as the default black, and it, while I'm talking about what I've discovered since last week, whenever you're twisting and moving your Visual Python around, you can use the right mouse click to basically twist it in space, or you can use left click and a control to twist it in space, or if you use left click and shift you can move it in space. So that's very handy. Anyway, I was having trouble with my coordinates, so I put myself some axes to help me work out where things are, how big they are, where the origin is, etc. This is something you can turn on and off. In fact, there's a few things you can turn on and off. I turn on and off the axis, and I've got this other function which I can turn on and off, which I'll show you later. Anyway, there's my axis. Here's my pseudo data. Later turns out to be now. Anyway, pseudo data is a function I call whenever I didn't have my Arduino ready, or as it happens I was programming away from my Arduino, so I basically had a function that returns me a bunch of numbers to exercise the dials just with random numbers. So what are my dials? Well, whatever they are, they're held onto a panel again, and they're held on with screws. I needed quite a lot of screws, so here's my first function, is for a screw. It gives me a virtual bag of screws. Not a lot going on here that is different from last week. The screw is actually more detailed, so I draw different pieces of it. They're all set in space. You pass over a vector, so this is like a basic screw, and then everything uses this vector that you pass to move it around, so you can put the screws where you want them, and as it happens I want them in the corner of every panel. So that's it. Screw with a crosshead, and the crosses are random. First, class now. This is another grand idea from Keith. And I also had to go back and watch one of Paul's other videos in his Python series where he talks about classes, and it's all about yourself, or itself, the class itself. So I'm passing over into the init function a bunch of stuff. I want to pass over the position of where I want this meter. I want the color. I'm passing over some information so I can do a scale, and I'm passing over some a label and some units. Type 1 is basically the square voltmeter that we've seen last week. We'll see again. I maybe want to have more than one. As it happens, I only needed the one, but I was in the flow for classes, so this is a class 2 even if I only needed one of them. Anyway, I take out all the stuff and put it into the self. I then start drawing this meter. There's a lot going on here. One thing that isn't going on, which is going to come later, is more in the defensive coding thing. I take in some values for this, like these scales. I take them in as verbatim, as in I don't check them. Later on, when we're updating it, I got a value for it. I don't check that either. I should, but I don't yet. Anyway, we draw a meter. It's got a panel. It's got a scale. It's got ticks. It's got little numbers along the scale. It puts in some text for my. This is all the same as last week, but this is my text for my my raw stuff. These raw things. So this is text for the labels. This is text for the raw values. I screw it onto the panel, and then I put a glass cover on it. At this point in time, when I initially draw it, or initialize, instantiate this class, I don't have any data for it, so I put up a warning, no data. We shall see that later as well. Another function in with this class is I want to obviously update it. So it's the same code as last week, just in a different position where I get the value in, and then I work out where to point the needle as a result of having said value. I also update some of these text labels, and that's it. Well, if I do have real data, I turn off the data warning. On the other hand, if I stop getting real data, because say the pot starts returning -1 for some reason, which I don't know yet, it'll turn on the data warning. Then I've got a meter type 3. Yes, that was a type 1. And this is a type 3. I haven't written type 2 yet. I'm going to have a round meter because Keith had a round meter, so I'm going to have one too. But I haven't had time to write it yet. Similar sort of story here. I pass over stuff when you instantiate it. I don't check what it sends me. I draw this type of meter. Whereas this one is my regular rectangle one. This one is a thermometer. It's got a ball at the bottom and a wee like the rising mercury that can go up and down. It too is on a little panel which is screwed on, and it's got a glass case, and it's got some screws in the corner, and it's got a raw value as well for what was actually sent over. It also has an update. I can pass over a value to change obviously the thermometer. This is where I have to get a wee bit clever. What this is trying to do is it works out the range that the meter is covering, which we give it here. In these are just the defaults, but in one of mine I pass over -10 to 80, or was it 70? I can't remember. But the point is, you have a range, and then what you have to do is draw the bar as a proportion of that range. Now the actual full height of the thermometer bar is 100% 1. So what I try and do is work out the proportion of the reading that's been sent over the size of the full bar, and then I also have to adjust it for the fact that my bar might start at -10, it might not start at 0, or it might start at -20. So I take that into account and work out the height of the bar to be displayed. Again, we've got turn off the data warning. There's no data at the beginning. Then when data turns up, which in the case of the DHT22 is several seconds later, 2 seconds later. It's a very slow sensor. Anyway, turns off the data warning or turns it back on if the data stops coming in. And this is where I use these classes and I stamp out all my meters. So I'm doing doing a 1 type 1 and then I'm having 4 type 3s. So I'm using a thermometer type for the temperature that comes from the DHT11. This is the DHT11 here. And I'm going to use a thermometer for the humidity, and then likewise to tell the difference I'm going to have them as different colors. The temperature will be a red bar and the humidity can be a blue one. This here is interesting though. I also display the units at the side of my thermometer, and this is the UTF-8 way of getting the degree sign, that little circle. See, that's how I get it, and you'll see that. And that took me a while to find out. Anyway, then I put my logo on it, and I've got 2 logos now, well, just to give the thing a name, and then finally I put all of them on a nice grey panel. And of course the grey panel needs to be screwed to the screen, so I screw it down too, because I tell you, I've got a virtual bag of screws. I can have as many screws as I want. Now, this is getting into open up the serial port. If I'm not doing real serial and I'm playing with my pseudo data, I've wrapped it up so that it doesn't even try to open up the serial port if I know my Arduino isn't there. So it'll only open it up if it isn't there. If it is there, but if I'm trying to use the Arduino and the Arduino actually isn't there, then I'll get the same serial error. It flashes up in front of the screen. Now it's not over a meter, it's over everything. Then we're into the infinite loop, where we're reading in this CSV data, assuming we're not in pseudo data mode. We read in the CSV data. I strip off the carriage return line feed at the end. Obviously I've stripped it from being byte code into string, and then I strip off the carriage return line feed, and then this is what you can do to split up the CSV. You can put it into, I've got 5 variables. Again, it's not defensively coded. If somebody sends me over 4 or 6, my code will probably fall apart. But I'm sending over 5, so I pop them into 5 variables, splitting on a comma. Then this is if I don't have anything from the pot, I will get a -1. If I don't get -1, then I've got something useful. I'll convert it to an int, because these are strings until I make them numbers, and I do that. Then we've got the nans that might come across from these sensors, and I convert them to floats. This is my toggle for turning on and off the serial error if the comms port isn't found. I didn't mention this last week, but this is quite a clever way of using modulo 2 maths to toggle something on and off between 0 and 1. And if I were in the pseudo data mode, would be getting my 5 pseudo numbers from the pseudo data function up top, and then this is where I call my update method in my class. Method is just a function in a class. It's still a function, it's just in a class, and it's got a clever name of a method. Anyway, I call the update method for my 5 meters, and they get updated. Now, without further ado, why don't we run this code? And it does take a while to run on this machine, and hopefully my video doesn't fall apart, because I can tell you there's a bit of 3D text being printed, and that is quite heavy on the PC. This text prints slowly. What it says in the vPython notes, 3D text is expensive, and boy it is. But anyway, let's run this up. My Arduino's working, cool term is gone, so let's press that button, and then we'll switch to another screen to see what it's going to do. So we are waiting on it appearing, and here it comes. and it starts to draw. So this will rescale itself as it starts drawing more stuff. You see the no data has turned up here because there is no data yet. Now it's drawing the DHT temperature and the humidity. There's my degree sign coming in. There's no data for any of this stuff yet. It actually hasn't even connected to the Arduino yet. That's how long it takes to draw this. And it's all this 3D text. See, this scale starts at -10, goes up to 60. Yeah, -10 to 60. This one is just not the 100 percentage. That's what humidity is measured in, or relative humidity. Now it's drawn my Easy Face logo. And we're nearly there. There we go. And it's now starting to get data, and there we are. If I turn the pot, it starts to move. There we go, live data coming in. The temperature is nicely on the thermometer. The numbers look the same as what I was getting before. The independent thermometer is telling me 18.9. The DHT22 thinks it's 19.1, whereas the 11 is 19.8. So always off at the DHT22. It does seem to be a better sensor, even if it's much slower. Having said that, though, reading temperature every 100 milliseconds is pointless. Anyway, there we go. Let me show you the shift to move this around, which is a revelation for me when I found it during the week. And then of course there's control to twist it in space. You can see I've got glass panels over it all, and in fact my screws go right through, and if you turn around you can see them coming through at the back. Anyway, that is my Easy Face meter panel, giving all my Arduino data a nice colourful metering. Anyway, that's it. Thank you for watching.